action.
All right. Good afternoon, class. My name is Firefighter David Rawlings. I work for Central County Fire and Rescue. The class that we're going to be running through today is Firefighter Personal Protective Equipment. Before we get started, I would like to let you know where all the exits are. So if you go out both of these doors to either side, in case there's an emergency, there is both exits on either side of these doors. If there's a tornado in there, we do have a tornado shelter on the far side of the apparatus bay. I would like to ask at this time if you could please hold your questions to the very end. I would appreciate it. Today's objectives, what we're going to be going through is upon completion of this class, you should be able to describe and the inspection process, the cleaning process, and the maintenance of your PPE. You will be able to describe the conditions that require the use of respiratory protection equipment, as well as identify basic SCBA components and describe the SCBA limitations. You'll be able to explain the process of inspecting and cleaning the SCBA properly, as well as describe the safety considerations for working in and exiting a hazardous atmosphere while wearing an SCBA. We'll be running over skill sheet number 10, which is routine SCBA inspection, as well as the cleaning procedures. So let's just jump right in and get started. All right, so to start off with, all the proper use of PPE, I think you want to make sure all the closures are fastened, the face piece is properly in place, and the air cylinders are activated before entering the structure, obviously. You want to make sure that your helmet's face shield is down to provide a secondary layer of eye protection, or you can also wear secondary goggles, but depending upon how your new helmet works, you either have the flip down style or you have the little goggles that flip down in place of the full face shield. Quick inspection of the PPE to ensure it's properly done before entering and exiting the structure. Traditionally, that's why we're on the buddy system. It's always 2 in, 2 out. So once you don your PPE, you should look at your partner. You should visually inspect him to make sure that his hood's properly in place and there's no visible skin. He should do the same to you in return before entering the structure. Just a warning, you want to always wear the correct PPE that is designed to protect you from the specific type of hazards presented by the incident. So for example, obviously if you're going on a hazmat incident, yes, we're going to wear this, but depending upon the type of hazard, you might want to get in a Class B suit, Class A suit. But for most of what we do, our PPEs will provide proper protection, unless otherwise designated by the battalion chief or incident commander. Wearing appropriate PPE, you want to obviously, for respiratory protection, you want to use the PASS device. There's helmets, there's the coat, the trousers, the boots, the protective gloves, protective hoods, eye protection, as well as hearing protection. I don't really recommend using hearing protection inside a IDLH environment because it's already hard enough to hear, but that's on the slide and we will have to cover it. But you always obviously want to protect your hearing because of what we do in general for a living with high noise levels. If you're just running the tools in the morning, take the extra time, get some hearing protection put in before you start the tools in the morning. It's just an added layer of protection. The types of PPE, obviously you have station and work uniforms, you have structural firefighting PPEs, as well as wildland PPEs. There are different roadway operations which require us to wear certain square inches of yellow reflective vests. Some PPEs do have that already integrated within the coat itself and the pants. They have the proper square inches of the reflective tape on the turnout pants as well as the turnout coats. Obviously, emergency medical PPE, we all know goggles, gloves, N95s. Special PPE such as obviously the chemical protective clothing, Class A, Class B suits. Station and work uniforms, this will completely depend on your department, on what they require. Some departments will let you wear black tennis shoes, others require steel-toed boots even for station use because a lot of their boots are also wildland rated as well as structural rated. Just a quick note, to refer to the department's policies concerning what can and cannot be properly worn underneath your PPE. For example, some departments won't let you wear like nylon, like workout pants or workout clothes because of the burn factor. If you want to wear cotton, that's okay, but some departments are still old school and they don't want you wearing that because of obviously prior incidents of guys getting in a bad environment, getting caught having nylon pants on and literally having them to be peeled off their legs. So just FYI, just make sure you check your department's policies. Do not wear clothing made of non-fire resistant synthetic materials under your PPE. Click. Stations and work uniforms should meet the NFPA 1975 requirements, have a compliance label attached, and they are designed for fire resistance but not for firefighting operations. They may be worn under structural or wildland PPEs. And some are dual certified as work uniforms and wildland protective clothing. Most Nomex firefighting work duty shirts and duty pants that are made of Nomex meet that last qualification as far as wildland protective clothing. So they do, some people, they'll actually put brush gear over them so it provides a double layer so you're still insulating well, but it just depends on the department. Excuse me. Station and work uniforms, obviously there's different types of shoes that are required at the station. They usually have steel toes, puncture resistant soles, or special inserts. Do not wear during emergency operations. Obviously you don't want to go into an IDLH with station boots on, or really run any kind of fire call, whether it's wildland, no matter how mundane or minuscule it is, because things can go wrong. For contamination, obviously, we don't take our uniforms home. We do not launder uniforms in personal or public machines. Uniforms must be laundered at the station or by a specific contractor. Structural firefighting PPE includes helmets, trousers, eye protection, protective hoods, coats, boots, and protective gloves. NFPA 1971 compliance. These are all the labels that are inside your turnout gear. And for this just happens to be a Globe firefighting suit, and they will say that the structural firefighting protective garment meets the garment requirements of NFPA 1971. Warning, unauthorized alteration of your PPE may expose you to fire scene hazards and endanger your life. So do not personally modify your gear. Any modification has to be done by an authorized agent or dealer. And always you want to seek your specific department's guidelines for that procedure. Unauthorized alteration of your PPE, whoops, hold on. There you go. Heat transfer from PPE to the body. The PPE is designed to cover all skin and prevent heat transfer to the body. The PPE has limits to the amount of heat that it can absorb. A hot PPE can cause contact burns, which is why you don't want to ever grab somebody by the arm or touch them on the shoulder. If you're trying to get their attention, try to pound on their tank. Try not to touch that, because once you compress all that clothing and you bring that in, you're really exposing them to all that heat will transfer down to their skin level. The time that PPE takes to reach a danger absorption limits depends on the heat transfer rate. Obviously, how hot the fire is, what particular type your PPE, what type of condition your PPE is in. If you have old, really ratty, old school PPEs, probably want to look at replacing them because they're not going to have the same thermal barrier. Heat transfer from PPE to the body, as we just covered this. So personal protective clothing can trap heat and humidity inside. The PPE absorbs and stores heat and can take longer to cool. Follow proper protocol for cooling PPE. PPE prevents the heat transfer away from the body. PPE traps the heat and moisture inside, and they significantly increase your breathing, your heart rate, skin temperature, core temperature, as well as psychological stress if you are not used to it. This is why it's also a very good idea that it's really important to stay in shape so you get used to having your heart rate elevated, so that way when you do go into that environment, it's not something that your body is unfamiliar with. Helmets. So helmets are to prevent heated or scalding waters and embers from reaching the ears and neck. It also aids in keeping water running down the back of your collar. It protects the head from impact injuries and provides protection from heat and cold. Helmets can help identify persons or personnel that obviously they have to wear it correctly. You want to always make sure that chin strap is secured and your ear flaps are down and your neck, and to cover your neck as well, just for an extra layer of protection, and make sure it's properly adjusted to fit the individual. Eye protection. So there's different types of eye protection. Obviously you have the SCBA face piece. There's the helmet. There's the old school helmet face shield, which is a lot of departments are kind of going away from. Obviously for wildland firefighting, they have individual goggles that set up, and this is kind of the new style of helmet kind of integrates these safety glasses, and they actually are internal and they slip down they're kept inside the front helmet and they actually slip down, but they look just like a pair of safety glasses. They're pretty slick. Face shields alone, whoops, sorry, I hit the bar on button. Face shields alone do not provide adequate protection. NFPA 1500 requires that appropriate primary eye protection be worn at all times in hazardous situations. Some situations require eye protection, but not respiratory protection, such as if you are cutting the lock off of a door, or cutting open like you're doing any type of physical extrication from a car. So caution, metal frames on prescription glasses can transfer heat to the skin even when they are covered by safety glasses. So obviously if you have wire-rimmed framed glasses, yes, they could transfer the heat to your skin and you could get an isolated burn. Protective hoods. They are fire resistant, they are not fireproof. Mostly made out of Nomex material. They're normally dual layered. Some of the newer ones now, they don't have that dual layer, but they are marketably thicker than the dual layer. They are fire resistant. They protect your neck, your ears, your face from exposures to heat and embers and debris. They cover areas that may not be covered by the SCBA. The elastic edge forms a seal around the face piece once you put it on, and you have to make sure that that's adjusted properly so you do not have any space that leaves any exposed skin. And the skirts are designed to fit inside the coat. That's why they're longer and they go way below the neckline. And obviously you want to put the hood on before the coat, so that way your coat is laying over the top of it and your neck is already secured. And then secure the SCBA face piece before pulling up your hood. Protective coats. Obviously there's an outer shell, there's a moisture barrier, and there's a thermal barrier. The moisture barrier and thermal barrier are always usually secured into one piece of clothing for your liner, but there's the thermal barrier that's on the inside, and the moisture barrier is on the outside next to the outer shell. So the outer shell is A, B would be the moisture barrier, and then C would be that thermal barrier. As a warning, all layers of the protective coat must be in place during any firefighting operation. Failure to wear the entire coat and liner system during a fire may expose you to severe heat, resulting in serious injury or death. I would like to kind of state this as a duh. So yes, always wear your protective clothing in an IDLH environment. Protective coats. There's many different styles of coats. This just happens to be one style. It's not these particular things aren't necessarily on every coat, because some have zippers, some guys still use the old style metal clips, some guys just have a double Velcro strap closing on them. But there is a closure system of some type, right, regardless of what it is. There's reflective trim, there's a collar, there's more reflective trim on both sides to give you that proper, some have the correct amount of square inches so they don't have to wear the vest, but most people are wearing vests. Most now come with the DRD, which is a drag rescue device, so that if you need to pull out, your partners can obviously just grab that, however they're going to manage to drag you out, and it sits just behind your SCBA, so it's very easy to grab. Next. Protective trousers, the same materials and closures systems as protective coats. So again, they have the same barriers. They have their outer layer, their moisture barrier, and their thermal barrier. Their reinforcement compression areas, such as the knees, they have usually cargo pouches or cargo patches. They're heavy-duty suspenders and reflective trim. Protective gloves. They protect you from heat, steam, cold penetration, their resistance to cut and punctures, as well as liquid absorption. They're not waterproof, but they do resist moisture and water. You also must allow for the dexterity in feeling and grasping. And they cover the wristlets to complete and form a seal. They must be also NFPA compliant. You can't just grab just a generic pair of thermal gloves or work gloves. It's not the same thing. They're made out of special material. Protective footwear. So you have the fire boots. There's regardless of what style of fire boot you have, these are the basic same components that are going to be found no matter what the manufacturer. So obviously you have the boot loops, you have the foam cushioning, there's a waterproof layer. Some you may find rubber or leather. Sometimes they have reflective material, sometimes they don't. There's usually some type of moisture barrier on the inside. A lot of them now have Gore-Tex, so it helps your foot to breathe. There's some foam cushioning. There's usually a stabilizer heel cup. I don't know of any structural firefighting boots that are not steel-toed. And there is a puncture resistance. Usually it's some type of either carbon fiber or steel belted puncture resistant midsole. The personal alert and safety systems are pass device. This is an alarm. So it's emitted to alert personnel that the firefighter is in danger. This activates when the firefighter is motionless for more than 30 seconds, or when the firefighter presses the emergency button manually. So if he does get in trouble, he doesn't have to wait the 30 seconds, they can just manually press the button and it will automatically sound. Some models may activate when the temperature exceeds a certain preset limit. That will completely depend on the manufacturer of the SCBA or pass device. And they must be, all pass devices must be at least 95 decibels and go off continuously for at least 1 hour. So those are the minimum requirements regardless of the manufacturer. They help to assist rescuers in locating trapped or unconscious or incapacitated firefighters. They are useful in total darkness and dense smoke in confined spaces. The personal pass alert system. So again, this is an older Scott model, but again, they're all going to look a little different, but they're all going to basically operate under those NFPA guidelines. So they may be a standalone. I don't think anybody is using these anymore, but I could be wrong. Most of them are always integrated now to the SCBAs. They may activate audibly or manually. We already covered that. The modes, they're either off, they're alarming, they're sensing, or they're in a pre-alarm mode. Hearing protection. So obviously we have a multitude of different types of hearing protection. So you have the foamy ear plugs, our communication headsets that we utilize on the truck when we're running to and from calls to help us from evade the engine noises, and the standard earmuffs that people use. And I would again recommend you put some type of hearing protection in, just to, again, you want to really try to protect your hearing, because if you don't use this, you will lose your hearing. So hearing is very important. Hearing protection, situations that may require hearing protection. Obviously riding on the apparatus where noise exceeds the maximum exposure levels, operating power tools, the apparatus pump and generators, and during pass device tests. Everybody should be using that because as it sounds, it is over 98 decibels. Hearing protection may be dangerous or impractical in some situations. We did cover that. Obviously, you don't want to use any type of hearing protections if you're going into an IDLH, because you want to be able to hear as much as you can. Wildland PPE and gear. So you actually have a lot of the same things that you're going to wear on a wildland firefighting operation as you will in a structure firefighting. They're just going to be not as heavy, not as thick, and not as much of a thermal barrier. So obviously you have gloves, goggles, jackets, trousers. Sometimes they use one-piece jumpsuits. And always long sleeve shirts. Sometimes they actually have a brush jacket that they put over it, like that yellow one right there, all of which should be made of Nomex. Next. So wildland PPE and gear. Obviously there's helmets, there's face neck shrouds, there's footwear. There's a lot of the gears as you go out onto a wildland firefighting campaign. They have a web belt, like a harness almost, and they have certain amounts of equipment that you have to carry. Obviously, you want to be able to carry water. Fire shelters are the biggest one. You have to, all wildland firefighting members must carry a firefighting shelter at all times. We used to conveniently call them the baked potato sack, because they're basically a foil shelter that you can pull over yourself, and it kind of has a elastic covering. Almost looks like a great big shower cap, and you pull it underneath you and you want to try to mat it down flat to the ground, and hopefully the fire will pass over you quickly. Load carrying belt or equipment, respiration protection. So there's a multitude of those too. So some people actually have the mask that they strap on their face. Some people, they're a shroud that actually covers the face and the ears. There's obviously chainsaw protection, obviously, so you need to have your safety goggles on, any type of hearing protection, your water, backpack or web belt for extra gear, and fusees. Fusees you need for two things. One, if you are setting a landing zone for a helicopter for pickup, or if you're going to be setting backfires. Wildland PPE and gear continued. They will not protect you from extreme heat. Again, this is one of the main differences between structural firefighting gear and wildland firefighting gear. And again, you want to make sure that you never wear any type of synthetic clothes underneath your firefighting gear. Again, no nylon running pants, no nylon shorts. Again, it's really important because if you do get stuck in a situation where you're going to get burned, your burns are going to be significantly worse if you are wearing nylon pants. NFPA 1500 specifies a minimum of PPE for ground cover firefighting, wildland firefighting. Helmet with eye protection and neck shroud, obviously flame retardant shirt, pants, or a jumpsuit, protective footwear, gloves, and obviously you're mandatory, you must carry a fire shelter at all times. So as a warning, wildland PPE is not designed, certified, or intended for interior structural firefighting. So roadway operations and clothing. No PPE can prevent injuries from a moving vehicle. So that's why it's very, very important to be heads up. Being out on the highway or any type of street environment is probably one of the most dangerous things that we do in our profession. The best protection is to obviously work behind an apparatus barrier. So positioning the apparatus to protect us while we are out on the road is paramount. Personnel must wear an ANSI-rated reflective vest when performing activities other than firefighting or hazardous materials operation. Safety considerations for PPE. Obviously, this is a little chart that shows you heat transfer through protective clothing. So here would be our routine clothing. This would be ordinary clothing. This would be emergency. Heat protection from a PPE can prevent awareness of environmental changes, because if you're wearing to something, you might not realize how hot or how dangerous something is. Safety considerations for PPE. Consider the garment's design, purpose, and limitation. Obviously, moisture can transfer heat rapidly. You want to always ensure that the garment is dry before wearing it into a fire, because steam burns are something that's very serious. And if you've never been steam burned, good for you. If you have, you will know exactly what I'm talking about. So PPE insulates you, which will delay your awareness from the temperature increase. Old school guys, some people still like the thinner hoods for that reason, because if you wear something that's really thick, some of the old school firemen will tell you they used to be able to judge how hot it was and the danger point when they could feel it on their ears. So, but some of the thicker hoods don't allow that anymore. You can't hardly feel any of the heat. So you can put yourself in there because your PPE is so effective. So just keep that in mind. Never wear PPE that does not fit properly, and make sure the coat and the trousers overlap a minimum of 2 inches at the waist, so that when you bend over at a 90-degree angle, you still have enough coverage to prevent you from getting burned. PPE will impair balance and gait to a certain degree. That is true with everybody. However, the more you wear it and the more comfortable you become with it, you should be able to overcome that. Thermal burns may occur at compression points. Again, that's why we don't want to touch anybody on the sleeve. You don't want to touch anybody or grab them by the arm or push on their back. If you need to get their attention, you want to try to pound on their tank or yank on it to get their attention. If you feel a contact burn developing, withdraw immediately. You can get this even if you lose your balance crawling down a hallway sometimes, trying to drag the hose, and you accidentally lean and you touch it and you push your shoulder against the wall. Just something kind of to keep in mind. It's a good gauge to how hot that environment actually is. So obviously you want to move to a cool, safe area, remove your PPE, and follow rehabilitation procedures if you feel symptoms of heat exhaustion. PPE is not designed to protect you against rapid fire development. So it will not protect you from a flashover. Safety more considerations for PPE. PPE can also absorb heat until it is hotter than the ambient temperature. PPE can cause heat and Velcro components to fuse together, so that way when you go to try to pull the coat off, it won't come off. They're actually melted together. So that's still a lot of some of the departments won't use Velcro at all. So, or at least not on the main opening of the coat. They'll still use it for the flap around the neck, but you're only talking an area that's this big. If you have a huge 2-inch or 1.5 inch strip going all the way down the coat, it can be problematic, and you may have to cut it off. Buildup of heat will eventually penetrate all layers of the PPE if given enough time and if the environment is hot enough. RIT and rescue personnel must exercise caution and wear gloves when removing PPE from a firefighter that they have just removed from an IDLH environment, because he will be superheated. All of his turnouts, all of his turnout gear will be at a very, very high temperature level. And obviously you want to evacuate the structure if your PPE or SCBA are damaged during firefighting operations. So burns are a result of time and temperature. The longer the exposure and the higher the temperature, the greater the severity for a burn. First degree burns start when the skin temperatures reach 118 degrees. Second degree burns start at 131 degrees Fahrenheit, and third degree burns start at 152. Just a review questions, how does structural firefighting and PPE differ from wildland firefighting PPE? Well, obviously, we can talk about that a little bit, but obviously there's just less thermal layers. It's not as thick, so they're not rated to protect you from those high level temperatures. Wildland firefighting has a very low temperature threshold. So how does structural firefighting and next. Why is it critical to wear the correct PPE for the situation? Because you don't want to wear structural firefighting gear while trying to attack a brush or grass fire, because now you are encumbering yourself by wearing something that is much, much, much too heavy to be tromping through acres of field or grass or mountainous regions trying to operate in a wildland field while wearing the wrong PPE. Let's see, you receive a call that a storage building and someone's rural property is on fire. What is the appropriate type of PPE to wear for this situation? Sorry, this reminds me of a call I recently went on. I would say, again, if it's a structural building, what does that tell you? You're going to be wearing your structural PPE gear. Whoa, you win this one. There you go, learning objective 2. Describe the inspection, cleaning, and maintenance of your PPEs. So the preparation for PPE for reuse. Obviously, the PPE can cause illness or injury if not properly maintained. The hydrocarbon contamination reduces firefighting resistance. Chemicals, oil, and petroleum products on the outer shell can ignite. Contaminants can reduce the effectiveness or the retroreflective trim. Wow, say that 3 times fast. Retroreflective trim. Hydrocarbons and body fluids and toxins that contaminate the PPE can be inhaled, ingested, or absorbed. That's really gross. You are responsible for inspection and cleaning and conditioning of your own PPE. Inspecting PPE for damage or contamination. Obviously, you want to fully inspect your PPE at the start of every shift and after every use. So every time you go to a fire, you obviously want, once you're in a contamination zone, whether you're an IDLH or some type of hazmat material, you want to go ahead and decon all of your stuff. But you also want to inspect it for rips, tears, any type of malfunction or any type of damage that occurred during that call. And obviously, after every use, after washing and repair or decontamination, or just on a periodic basis, depending upon what your department's policies are, you will mandatorily inspect your gear once a month, or triannually, or biannually, or quarterly. So just know that you know your department's policies and procedures for deconning and inspecting your gear. Conditions to look for during a routine inspection. Obviously, soiling, contamination, missing or damaged hardware, and the closure system. Physical damage, rips, tears, frayings, hems, cuffs, damaged stitching, wear due to friction. You'll see a lot, sometimes you won't realize it, but like sometimes you'll get your pants hooked on something and you'll have a tear in the back of your pocket because once you put them on, it's behind you and you don't see behind you, and you'll have somebody come up and go, hey, you got a hole in your pants, and you're like, oh, look at that. So look out for everybody else. If you see somebody that has a hole in their turnout gear, make sure you tell them and notify them because they might not know. Obviously, you want to look for thermodamage, charring, melting, discoloration, burn holes. I don't think shrinkage is a huge problem with PPEs as far as the material. I think people may change size, but not usually the PPEs. Damaged or missing reflective trim, obviously, which has to be repaired professionally. Conditions to look for during routine inspection: loss of reflectivity of shell or proximity equipment, cracks, melting, abrasions, dents in the helmet shell, missing or damaged face shield or hardware, missing or damaged ear flaps, or neck shroud. So obviously you want to inspect your hood to make sure there's no holes in it. Any loss of watertight integrity in the footwear. So if your boots have holes in them and your feet are getting wet, that's a problem and you know it's time to replace them. Any damage to any faulty installation of the DRD or drag system. Date of manufacture determines time in service. So again, everything has an expiration date on it, and usually it's about 5 to 7, depending upon the manufacturer. They used to be 10 and now they're saying every 7 years, so it just depends. Obviously there's routine cleaning you can perform yourself. Advanced cleaning or decontamination or repairs or replacement, you're going to report it to your supervisor. An annual inspection performed by the department member who is trained in advanced inspections. Only personnel trained to certify or repair PPE should be allowed to conduct repairs. And that's dependent upon your department. And we're back. Is it still running? Okay. And we're back. Obviously cleaning PPEs. There's routine, which means you can basically just, like, for example, this shows this guy just wiping off his helmet. Always clean your helmet, wipe it off. Don't let it get that nasty black stuff on there, because it's some of the newer guys, they think it looks cool because it looks like, you know, I'm gonna date myself, like Rescue 911, where they show up with the black helmets and all the soot on it. Wipe it off, because it's basically you're just carrying around cancer-causing agents, spreading it all around the truck and everything that it touches. Obviously, advanced cleaning. A lot of departments have extractors in stations. Specialized cleaning is where you actually have to wrap it in a hazmat bag, and your department will send that off to be professionally deconned and cleaned, and by a specific contractor of their choice. It is still running, right? Cool. Do not wash contaminated protective clothing in washing machines used for other garments or items, such as your home washing machine or public laundromats. This may expose you or your family members or others to dangerous contaminants or hydrocarbons. Do not take contaminated protective gear into the living sleeping quarters of your fire station or your residence. PPE should not be stored where it can come in contact with vehicle exhausts. PPE that is carried into personal vehicles should be placed in a concealable garment bag to protect it from sunlight and degradation, as well as to contain any kind of contaminants that are on it from getting inside your personal vehicle. Repairing PPE must be done by manufacturer, approved repair facility, or trained department member. Clothing damaged beyond repair must be removed from service and destroyed. Sometimes they will be repaired to a point where they can at least donate it to another department. Some damaged, oops, I'm sorry, I clicked it too fast. Go back. Some damaged clothing may be used for training that does not involve direct fire or IDLH environments. Just real quick review question: what can occur if the PPE is not properly inspected, cleaned, and maintained? You could get burned, right? Learning 3, describe conditions that require the use of respiratory protection equipment. The inhalation of smoke and products of combustion, Inhalation and smoke and product combustions are short and long-term fatal health, provide long-term and short-term or fatal health hazards. Some of the most effective way to protect your health is the use of an SCBA. SCBA use is required by NFPA 1001. It should be used in any IDLH environment and during overhaul. So that means you're wearing a full SCBA, your full PPE, face mask, on air. Types of respiratory protection and equipment. Atmosphere supplying respirators, or ASRs, provide breathable air in oxygen deficient, toxic, or gas-filled atmospheres, the primary type used in the fire service. Air purifying respirators, right? So there's your APR. We don't usually use those. Usually if we have our face piece on, we're on tank air. Some departments, I guess, have those, and they utilize your same face piece, but instead of clicking in your regulator from your SCBA tank, they actually have two filters on the outside, whether it's specifically just for airborne dust particles, and they have obviously different levels to like I know there's some that they use filters for different toxic, like vapor environments. Obviously this is like an EMS type just face mask, and this is basically your fiber mask, APR, like your M95 for just airborne particulates. Respiratory hazards, common in IDLH situation: oxygen deficiency, elevated temperatures, particulate contaminants, gas and vapors, and airborne pathogens. Don appropriate level of PPE and respiratory protection before entering any potential IDLH environment. It's very, very important and critical. Oxygen deficiency. So this is kind of what happens when your body becomes hypoxic, right? So standard, we're usually breathing 19.5% of oxygen in the air just during normal conditions. And obviously once you sink down between 19 to 15, your ability to perform any strenuous work decreases and coordination is impaired. Once your O2 level goes down and you're only getting 10 to 12%, you get dizziness, headaches, rapid heart rate, rapid fatigue. 8 to 10% exposure results in mental failure, unconsciousness, ashen face, blueness of lips, nausea, and vomiting. 8% in exposure for 8 minutes is fatal if you are exposed to an 8% oxygen environment for more than 8 minutes. And let's see, exposure for 4 to 5 minutes can be treated and resulting in recovery, but if it exceeds 8 minutes, it is always fatal. For 6% oxygen, a coma can occur within 40 seconds followed by death. This is just a little note on the side. This data cannot be considered absolute because it does not account for the differences in breathing rate or length of time exposed. These symptoms only occur from reduced oxygen. If the atmosphere is contaminated with toxic gases, other symptoms may develop as well. The synergistic effects of toxic gases combined with the reduced oxygen are not considered in the figure. This is just straight O2 saturation. This has nothing to do with any type of particulates in the air, any chemicals, any smoke. So just keep that in mind, because once you add those into this factor, everything now is ramped down lower, okay? So elevated temperatures. Obviously, breathing air is heated to flame temperatures that can have serious consequences. Decrease in blood pressure and failure of the circulatory system. So obviously, any pulmonary edema or asphyxiation can occur if you do inhale a highly heated atmospheric air. Obviously, if you do, you want to introducing fresh and cool air might not immediately reverse any tissue damage. Once you inhale it, the damage is done. Prompt medical treatment is required. Inhaling air that has been heated to flame temperatures can cause serious injury or death. Particulate contaminants is very harmful to the respiratory system and you might see cause all sorts of other issues such as asthma, lung cancer, cardiovascular disease, COPD, premature death. And obviously these are just some of the types of protection from those type of contaminants where you see these APRs with the filters. There's whole hood systems that you can see, but they're also used with a breathable system. These masks are usually sealed around here, and the filtering system is down behind their back. More particular contaminants, sources of particulates are chemical reaction, combustion, wildland firefighting, welding, and metal cutting operations, operating of firefighter apparatus, operations following an explosion or building collapse, structural fires, especially during overhaul. Gases and vapors. Exits at a standard temperature and pressure, example, natural gas. Vapors result from a temperature or pressure that changes results from temperature or pressure changes that affect a solid or a liquid. Example, steam. Okay. Inhalation, ingestions, or absorption. Obviously, there's cancers, thyroid damage, eye irritation, cardiovascular disease, as well as any type of respiratory problems. Fire and gaseous vapors, such as CO2, carbon monoxide, carbon dioxide, hydrogen cyanide, hydrogen chloride, hydrogen sulfide, nitrous gases, phosgene, that's really bad stuff, sulfur dioxide, ammonia, and formaldehyde. Firefighters must use SCBA when operating in or near toxic atmospheres. I know that kind of goes without saying, but it is important enough to restate again. Respiratory hazard remains during overhaul. Because obviously there's still a lot of particulates in the air that are floating around on the different thermal layers that are going through the structure. Hazards from the smoke increase as the size of particulates decrease. Does everybody understand that? That means that the hazard increases by the smaller the particulate, the higher the hazard. Hazardous concentrations may be present outside of the structure, even though you might not be directly in the structure. If you're standing close enough outside and you are on the windward side and that is pushing downwind and you are standing in front of those openings where the windows are blown out or the doors are open and you're still inhaling all of those particulate gases that are venting out of that house, you are still putting yourself at risk. Hazmat incidences can produce potentially hazardous gases and vapors. You always want to remain at a safe distance, uphill, upwind, upstream, until completion of the risk analysis. That will be determined by the incident commander or the area strike commander at that time. Always consider atmosphere and hazmat incidences to be dangerous, regardless of what anybody says. If you go into a hazmat incidences, it's dangerous, and you should treat it as such. Always wear SCBA until air monitoring demonstrates that it is safe. I will read this again. Always wear SCBAs until air monitoring. Nothing else will demonstrate that it is safe. Hazardous non-fire, man, I wish I was recording this one. Hazardous non-fire gases and vapors are always a possibility at transportation incidences and in storage and manufacturing facilities. Common types and their locations. Carbon dioxide is within any fire suppression systems. Ammonia, air conditioning, cooling, chilling systems, and agricultural applications. Sulfur dioxide, air conditioning and cooling systems. Chlorine, obviously water treatment facilities, water parks, and swimming pools. Also be advised, most swimming pools are now using chlorine gas because it's a little cheaper. So be heads up on that. Pesticides, commercial outlets, farms, nurseries, and residences. Other locations, sewers, storm drains, caves, trenches. They got their tank cars, bins, and any other confined spaces that you can possibly think of. Airborne pathogens, disease-causing microorganisms suspended in the air. They cause infection through inhalation or by direct contact. Encountered during medical responses, vehicle extrications, rescue and recovery, and terrorist attacks. Protection includes HEPA filters, APRs, PAPRs, and SCBAs. Okay, so in what type of conditions would the use of respiratory protection be necessary? And the answer is most anything we do, regardless of what it is. There's always something that's probably going on that would require us to do that. And second, why must firefighters always wear respiratory protection that is appropriate to the situation at hand? Because you don't want to wear something that's not appropriate. Wearing an N95 mask into an IDLH environment is probably not going to help you. Wearing a particulate filtering system APR is not going to help you if it's a vapor that's causing the hazard in that particular call, because you're trying to filter particulates, not vapors. So it's very important to wear the proper PPE. Now we're going to identify the SCBA components. So again, regardless of the manufacturer, you're going to find that most of the components are going to stay very, very consistent throughout the different manufacturers that are out there, such as Scott, MSA, and the other ones. But the open circuit SCBA operation, you're going to have a nose cup in the face piece, the bypass valve, the regulator, which is again is attached to the actual cylinder itself. You have a high pressure hose. Usually there's a low pressure system before it gets into the high pressure system, or high pressure system into the low pressure system. I don't know why it doesn't have that on here. This is your RIC pack, or your buddy breathing system. They're calling it a RIC or a UAC. Your hose and cylinder connection, your cylinder valve, your air cylinder, and your exhalation valve, which is in the face piece itself. Your closed circuit SCBA is your face piece, your exhalation hose, your inhalation hose. So this is basically a self-contained, this would almost be like a Draeger underwater SCBA that you're going to go scuba diving with. And this is a bubbleless device because the air it's a rebreather system, right? Because the exhalation hose doesn't allow the air to go out, right? So it's going back into that self-contained apparatus. Does that make sense? So this is right here is what the SEALs use when they go scuba diving, because they don't leave any bubbles, right? So the basic components, and just so happens this is a Scott, so this is what our department uses. So obviously you have the face piece here, you have the hose and regulator, right? There's the hose, there's a regulator, you have your waist strap, you have your low pressure alarm, you have your two shoulder straps, you have your pass device and pressure gauge, which is attached to the system itself. You have your air cylinder and the other waist strap on the other side. SCBAs may also have a number of other components unique to that manufacturer's design. Some of the ones that we do, they have different alarms that will automatically go off, giving any exposure to certain other elements. It just depends on what the manufacturer and what that particular department wants to pay for. So your breathing air cylinder capacities. These are the different capacities. So you have the rated duration, which is a 30-minute, 45, and a 60-minute bottle. Most departments now are going from 45 minutes and moving towards 60-minute. I don't know, there might still be some departments out there using 30-minute bottles, but I don't know of any around here. But obviously sorry, did I hit that button? Go back. So the 30-minute bottles, just to kind of give a frame of reference, so the lowest 30-minute bottle is basically 2,216 PSI, which basically gives you 45 square feet of air in the cylinder, where your largest amount of 45-minute bottle gives you 4,500 PSI of air. So it's a significant difference. And the only thing that really changes, even though it's the same PSI, is the amount of square footage per cubic foot that you can put inside the bottle. So obviously the bottle is going to be a little bit bigger. So, and obviously the more air you have, the longer you can stay in the IDLH safely. Your air cylinder assembly, your cylinder contains breathing air that's under pressure. It's constructed of steel, aluminum, or aluminum wrapped in fiberglass or Kevlar carbon composite. Most of the newer bottles are the Kevlar composite type. I don't think anybody's using steel anymore, or even aluminum. Cylinders weigh 8 to 20 pounds apiece. Obviously right here you have your threaded stem, your pressure gauge, and your valve control handle. Your regulator assembly. Again, your regulator assembly will also depend on the manufacturer itself. But a lot of the same components are going to be the same through them. Excuse me, depending upon the SCBA model, the regulator will have valves for normal and emergency operation, mainline and bypass valve. The face piece assembly, we've gone through this before. So here's your face piece assembly, here's your face piece. Now what they're considering is just the frame is what houses the lens, right? So here's your frame, this is the lens, and here's your interior nose cup, your regulator fitting, the exhalation valve and speaking diaphragm, and then your head straps in the back with the head harness. Face piece fit. A qualitative or quantitative fit test is required. That means they actually have to bring a specific machine and they have to fit those particular masks to each individual. Facial hair that prevents a complete seal is prohibited. Eyeglasses are prohibited if the side of the frames pass through the seal area. A lot of manufacturers like Scott, I know they have different little pieces that you can put in there to specifically hold eyeglass pieces inside the mask. Contact lenses are allowed if a firefighter demonstrates successful long-term use. Additional SCBA components, there's the remote pressure gauge, there's the end of service time indicator or the bell, or the alarms that have lights on them. So obviously if this is showing empty with the red, there's usually an amber light and 2 green lights. Rapid intervention crew universal air coupling, or it could be also a buddy breathing line that comes off, a buddy breathing Y that comes off, but usually a lot of them in the back also have this universal air coupling. Low pressure readings may not match the regulator gauge. Always assume that the lower of the 2 numbers is correct. That is a very good piece of advice because you always want to go with that lower number. Just automatically assume that that one is correct. Some additional SCBA components, emergency escape breathing support system or EEBSS. Usually you have a heads up display, and again, you usually have 2 greens, an amber, and a red light. And this is again, I can't speak for anything else, but I know that this is indicative of all Scots. The integrated pass control module, the alert lighting systems, and as well as voice communication systems. And basically, do everybody remiss the components found on the open SCBA is basically what we have, right? You have your line in, line out. You have a vent that breathes out the side. It's not self-contained. It doesn't go back into the system, right? And describe the SCBA limitations. Obviously, the wearer does have limitation. There's lack of physical condition, lack of agility, impaired balance, because it does throw you off because you are wearing that pack on your back. It does provide inadequate pulmonary capacity because if you do put that chest strap on, it does limit your chest capacities. Weakened cardiovascular capabilities simply because you're wearing a lot of extra weight. It's like wearing a weighted vest doing a workout on a treadmill. Psychological limitations, again, my opinion, the more you wear it, the more comfortable that you get with it. And unique facial features. Offsetting the wearer limitations is training. And again, offsetting the wearer limitations is training and more training. Obviously medical evaluations and make sure you have proper fit testing for your face piece. Equipment limitations, obviously you have limited visibility, you have the decreased ability to communicate because it is going to be harder to hear in an IDLH environment. You have a decreased endurance simply because you're wearing all the extra weight. Decreased mobility because now your hips don't move right because you're wearing the strap over your hips, you're wearing a shoulder harness on. For those of you who've been in the military, it's literally like wearing your plate carrier all over again with your K-pot and a 50-pound rucksack. Poor condition of the apparatus will also contribute to limitations as well as low cylinder air pressure. Overcoming equipment limitations is frequent and proper inspections, care, maintenance, and, say it with me, training. And review questions, what are some of the ways to overcome SCBA limitations? What's the number 1? Training. All right. What steps can you take to decrease SCBA wearers' limitations to increase proficiency while wearing the SCBA? And the answer is training. Very good. Describe the procedures for donning and doffing the SCBA. Common methods of donning the SCBA. Some guys will do this over the head thing. I personally would never do that because if you do start to put it over your head, like I was always taught, it's actually a safety thing because if you run multiple fires, chances are your gloves are going to be wet. Like especially because normally, even if you have a double set of gear, if you run one fire and you switch out, now you got all your dry stuff on, but everything else is wet. Well, if you get another fire, guess what? You have nothing else to switch into, so your stuff's going to be wet. So if you're throwing that tank over your head and your glove's wet and it slips, now it's going to crush your skull. So that's kind of a safety thing. Most of the people that I see will throw it on like a coat. They'll always throw it on one particular way, like I'm a right-handed guy, so I'll throw it over my left shoulder into my right. And when I throw it over, I'll step into it to make it a little easier. But that's just how I've always put it on. So even if it's facing on the ground, the top of the tank is here, the bottom of the tank is here. When I go to pitch it and I throw it up, I'll always just step into it and put it on. But that's just my particular method. We're lucky enough that most of our apparatus here at our department have them integrated into the seats. So if we're usually rolling them to a fire, we'll just put them on if we're putting them on in the back. Or the side mounted, I think some of the ambulances in St. Charles City that's an adjacent department that we work with, they have them back in the cabinet as well, and you can pull them, step back into the cabinet, put them on, and then pull them off of the rack. SCBA inspection prior to donning, you want to make sure the air cylinder and gauge and remote gauge, make sure they're full. You want to fully extend the face piece straps and harness for the back so your face piece is ready to go. You want to check for valve function. You want to test the low pressure alarm. You want to test the pass device. You want to check the battery operated functions to make sure that all the lights that are supposed to be working is working. These are basically what we call the morning checks that you do when you come on duty, right? So donning unmounted SCBA, right? So the SCBA positioned on the ground in front of the firefighter, and this is what we were just talking about. All straps extended. You can go over the head, or you can do the over-the-shoulder coat method. Donning from a seat mount. Only use this method if you can do so without removing the seat belt. That's really important. You don't want to take your seat belt off in a moving apparatus. Donning the SCBA from a seat mount, the cylinder must be held in place by a latching device. The face piece should be stored in a bag or a pouch, that way it doesn't get scratched or damaged. Do not keep the face piece connected to the regulator during storage. These parts are kept separate in order to keep the proper face piece seal, and it also checks, so that way if it's constantly put on that face piece, you're going to start to depress that seal that's on that regulator. That's why it's supposed to be put on that little safety cup that's on the outside, or its holster, right? Never connect the regulator and breathe cylinder air while seated in the apparatus. Doing so will delete your air supply before you arrive at the incident. Well, I really have nothing else to say about that, because yes, you shouldn't do that, and you shouldn't go on air until you're getting ready to go into the IDLH. Never stand to don the SCBA while the apparatus is moving. This is here simply because I guarantee you somebody got injured by doing that. Standing places both you and the other firefighters in danger of serious injury in the event of a fall or somebody running into the apparatus. NFPA 1500 requires all firefighters to remain seated and belted at all times while the apparatus is in motion. Don't remove your seat belt in order to don your SCBA seat-mounted SCBA. Donning from the side or a rear mount cannot be done. This is kind of funny. So this is saying that if you have a side-mounted or rear-mounted SCBA, yeah, you're not supposed to be able to don that while the truck is rolling down the road. It's kind of self-explanatory, but it's kind of funny. Requires more time to don than an SCBA seat-mounted, but faster than donning it an SCBA in a case. I guess some departments, depending upon where they're at, still keep them like in the big hard cases, but whatever. It does reduce the chance of slip and falls. Exposes the SCBA to weather and other physical hazards. The firefighters can don with little effort if mounted at the right height. Obviously, if you have different height firemen, then mounting it at a single level may be difficult for some and easy for others. Can be mounted near the running boards or tail boards. Donning steps are similar to seat-mounted SCBAs. Backup mounts. Well, that's kind of interesting. I've never seen that before. In a compartment protected by weather, some advantages to a side or rear mounts is quick access to SCBA. Compartment doors may interfere and compartments may be too high. May have telescoping frame mounts, and the donning procedures are similar to the seated SCBA. Some high-mounted SCBAs must be removed before donning. I guess that would be depending upon the height of the firefighter. Most face pieces are donned using similar steps regardless of the differences. Rubber harnesses or mesh skull caps, some have more straps than others. The regulator may be attached to a face piece or mounted on the waist belts or shoulder harness. Shape and size of the facepiece lens may differ. Donning the facepiece. You want to fully extend the straps. You want to ensure there is no hair between the skin and the facepiece seal, the chin in chin cup and harness at the rear of the head. Tighten the facepiece straps by pulling it to the rear. You want to check the seal, you want to check the exhalation valve, and you want to check all other connections. You want to pull the hood over your facepiece and cover all the exposed skin. You want to double check that, and then you want to wear the helmet with the chin strap secured and fit to adjust it. It's also a good idea before going into an IDLH is to look at your partner that you're going in with to make sure that, that his SCBA is fully covering his skin, specifically his hood. Because sometimes if you get in a hurry, one of those little straps will pull that hood back and he won't feel it. Or if he runs his hands over it, he might not feel it. So just double check each other. You want a doffing protective breathing apparatus. Make sure you're out of the contaminated area. Discontinue flow of air from regulator to facepiece. You want to disconnect the regulator and secure it. And then obviously you want to remove the protective hood. You want to remove your facepiece. And then finally you want to remove the backpack assembly. You want to close the cylinder valve. You want to relieve the pressure from the regulator. You want to turn off the pass device or control module. You want to, again, loosen all the straps. You want to make sure you want to check your air pressure, and if it's low, obviously you want to go refill your bottle or change your bottle out. You want to clean and disconnect the facepiece, and obviously once you get back to your station, the back plate and harness, and then secure the unit into its case or bracket when finished. So obviously what items should be checked prior to donning the SCBA? The SCBA itself. You want to check everything because it's your SCBA, so you want to check everything from stem to stern. You want to make sure you want to check the backpack straps. You want to make sure all your alarms are going off properly. You want to make sure all your lights that are supposed to be lit light up, which would give you an indication if you need to change the batteries. Again, you want to make sure that you have the right amount of air pressure at the start of your shift. You don't want to go on a call with half the amount of air in your bottle. And explain the process of cleaning and inspecting, explain the process of inspecting and cleaning an SCBA. Department schedules determines the frequency of inspection. Obviously, that's going to depend on each individual department, so you want to check your department's SOPs for the proper procedures. Inspections typically are performed daily, weekly, or whenever the firefighter reports for duty. The period between inspections must not exceed 1 week, which is usually not a problem considering there's 3 shifts. Must be inspected by a SCBA repair technician annually and after any repairs. Clean and inspect the SCBA after each use, at the start of every duty shift, every week. Any repairs, report any repairs needed immediately and take that if it does need repairs, take it out of service. And report it to your closest supervisor and have them get another one to you. Extensive repairs and cleaning may be required, the unit to be taken out of service or replaced. Daily and weekly inspections, obviously the facepiece, it's basically just like everything we ran through. The facepiece, the backplate and harness assembly, the air cylinder, any hoses, low pressure alarm, the regulator, pressure indicators, and the integrated pass device. Identify and any wear and tear, damage, potential problems before they result in a failure during an emergency, and should be documented to record findings, report problems, and show any trends in particular. If there is one particular harness or backpack assembly that's causing a particular problem over and over again, there might be something else going on with that harness and it needs to be looked at. During the inspection, the inspector should check the hydrostatic test date label on the air cylinder to see if the cylinder is due for any hydrostatic testing. Check for flaws and or leaks. Clean and sanitize the facepiece and seal after each use. Ensure proper operation of the exhalation valve, and then dry the facepiece with a lint-free cloth or air dry it. Do not submerge regulators or low-pressure hoses in water. That's bad. Anti-fogging chemicals may be applied. Check your manufacturer and your department's policies for that. Clean face pieces after each use, even if they are not shared. We usually don't, most departments usually don't share face pieces, but I'm sure there's probably some volunteers that do. Store face piece in a case or a bag or a coat pocket with straps fully extended. Annual SCBA inspections and maintenance. Okay, these must be performed by specially trained or factory qualified technicians and according to the manufacturer's recommendations. Fire department personnel or certified maintenance contractors. When should SCBA inspections take place? Depends. It should be taken daily before you come on duty, weekly, not to exceed 5 days in between each inspection cycle, and annually, and depending upon whatever your department's policy states. Describe the methods of refilling and replacing and storing SCBA cylinders. Stationary fill systems, mobile fill systems, firefighter breathing and air replacement systems, and they must provide type 1 grade D air. Could you see if we're still recording just to make sure it's still running? Okay. I don't want to go halfway through this thing and have it cut off because that would really suck. Check the hydrostatic test date. Inspect cylinders before filling and checking the working pressure. Where required, hearing protection and eye protection. Place cylinders in a shielded fill station. Fill the cylinders slowly. You don't want to fill them too fast. They get hot. It decreases the life of the cylinder. You want to ensure the cylinder is full but not overpressurized. Only allow trained personnel to operate the fill equipment. Do not fill cylinders if the hydrostatic testing is out of date or if the cylinder is damaged. Otherwise, you could very well have a very small torpedo on your hands. Let's see. Filling unshielded SCBA cylinders are prohibited while a firefighter is wearing the SCBA unless Rick is rescuing a firefighter. NIOSH approved RIC UACs must be used. Risk assessment must be conducted, and there must be an imminent threat to the safety of the downed firefighter. I'm not even going to comment. Stationary fill stations, most departments will have at least one of these and or something similar to this. So basically your breathing cascade fill systems, there's a compressor unit with air filters. They leads a line to the cascade cylinders itself, or the cascade systems, where it stores the banks of air. Then the line leads to the fill station, and the fill station is where you can regulate, and depending upon which cycle or which area you want to fill and which bottle needs to bleed off, because these bottles will go down out of order. They won't all go down the same because you're running off of one bottle. That way the compressor only has to fill up one bottle at a time, or 2 bottles at a time, instead of the entire system. So obviously there's a compressor unit, there's the air line, and it goes directly to the fill station. Mobile fill systems, they're just that. They're a mobile fill station. You can hook them up to the back of a pickup truck or a plug buggy and take them where you need them to go. Firefighting breathing air replenishment systems, or FEBARs, is used in high-rise buildings, provides endless source of breathing air. Replacing SCBA cylinders, you can either do this on the ground, or if you're at a fire and you're just coming out for a recycle, all you need to do is come back out, change your bottle. Usually your engineers, if they're a good one, they'll take care of you. They'll come out, you'll change your bottle out, you'll get back in, you'll notify the incident commander that you're ready to go back in, you got your bottles changed, and he will send you back to work. Empty cylinders, you want to keep separate from full cylinders, obviously, for obvious reasons. Any damaged cylinders, you want to clearly mark and keep separate from empty and full cylinders. Storing respiratory protection equipment, obviously you're either going to store them back in whatever particular storage area that you keep them, whether it's the seat on the apparatus, whether it's the plastic containers, whether it's in a side compartment or on the tailboard, or whatever they're properly stored. What types of systems are commonly used to refill SCBA cylinders? Cascade systems. Describe the safeties and considerations for working in and exiting a hazardous atmosphere while wearing an SCBA. Exposure to airborne hazards, fatigue, regulating air supply, and proper exit procedures. Safety precautions. Only enter the IDLH atmosphere if you are certified to wear an SCBA and properly fit and tested. You want to closely monitor how you feel. If you become fatigued, notify your supervisor and rest. Air supply duration can vary depending upon your air cylinder size and the beginning of the pressure you start with, and your physical conditioning in whatever particular task that you may be assigned. There's a big difference if you're just going in and you're just cooling down hot spots as opposed to pulling sealing or doing any kind of major overhaul, because you're going to be exerting a lot more energy. Again, your level of training, your operational environment, level of stress, and your air management technique, whichever you choose to use, whether you're using skip breathing, double breathing, holding, whatever your particular method is. Before entering an IDLH atmosphere, you want to check the cylinder pressure and estimate the point of no return, which will be indicated by whatever. It's going to always trump your department's policies and procedures are going to trump whatever the manufacturers are. So if your policies and procedures for your particular department say you're coming out at 50% air, you're coming out at 50% air. Establish a personal baseline for air usage. That is your own personal baseline. And then after entering an IDLH atmosphere, keep the SCBA on and activated until you leave the contaminated area. Improved visibility does not ensure an area is free of contamination. And before you remove your SCBA, the atmosphere must be tested and found safe. Work in teams of 2 or more in an IDLH atmosphere. Remain in physical, voice, or visual contact. Radio contact is not sufficient. I will say that again. Radio contact is not sufficient. Thermal imager can help to maintain contact, but should not be solely relied on. You want to check the air supply, obviously your status frequently, and as your incident commander should also be doing that as well. Exit an IDLH atmosphere before the low alarm activates. That's really important. Radio contact is not sufficient communication between team members in any IDLH atmosphere. Exit indicators. Always be prepared to make a rapid exit or withdrawals for non-emergency exit indicators and emergency exit indicators. Because your plan A will always turn into your plan B, which very well may turn into your plan C. So obviously, non-emergency exit indicators is a situation is stabilized, there's a change in operational strategy, it's necessary to replace an air cylinder, IC orders a non-emergency withdrawal, or the assignment is complete. Emergency exit indicators. This is an activation of an SCBA low pressure alarm, withdrawal orders from an IC or safety officer. Obviously, any changes in environmental conditions that you notice or see, or somebody else may see and communicate that change over the radio. Changes in oxygen level, indicators of a new hazard. The IC is responsible for constant monitoring. When potential hazard is revealed, the IC issues the orders to change required respiratory protection or withdraw completely from the IDLH. Report symptoms and evacuate the area immediately. Any lightheadedness, disorientation, loss of coordination, increased breathing rates, as well as any rapid onset of fatigue. Not just fatigue, but rapid onset of fatigue. Obviously, non-emergency exit techniques, you're going to have the buddy breathing, the buddy system, controlled breathing, and any type of egress points that you want to notify on the way. List at least 5 emergency exit indicators that would signal the need to exit a hazardous environment. What are the 3 non-emergency exit techniques that a firefighter should know and practice? Anybody? Anybody? Come on, we just went over them. No. So obviously, any change in environments, any notification from the IDLH, or change in any particular known hazard. You're performing a search and rescue at a structure fire. You see a person in need of a rescue in the next room. The incident commander calls for the emergency evacuation before you can reach them. What do you do in this situation? I'm going to change this a little bit because this is a little vague, but just for fun, we're going to do this. So let's say he's from me to Chris. I can see him, and it's really borderline like, ooh, you know, it's looking really bad, but I can like see him, clearly see him. The commander tells you, everybody out. At that point, what are you going to do? Just think about it for a second. What are you going to do? Because I know what I'm going to do. What are you going to do? Oh, we have a question. Yes.
If it's Chris, I'm probably going to go get him. There might be somebody. No, I probably. It depends who it is.
Well played. What if it's a citizen? You gonna go get him?
Yes.
Yeah, you're gonna go get him. Because I know that's what I'm gonna do. No questions asked.
Yeah. Emergency radio
and it's
traffic.
fun. And look, but here's the thing. So this was a rookie question given to me by an apparatus operator. And apparently, the rookie that he had asked me, that was one of my former classmates. He did not answer that correctly, because he went with the the commanders, the IC said, get out. I'm like, well, guess what? it's an unlawful order. Go, no, we're not doing that. I'm going to go get him because I can see him. Life and property, right? What's the first one? I mean, but it's just something to, but that one's kind of vague, so I just thought I'd give that out to you. So, next. Are there any questions about this content?
No, great job.
Cool. I think we're done. Thank you for your time. I'm going to pass out a test real quick to give the evaluation here. So we have a 10-question test. I'm going to hand this out. It's going to be really difficult. Boom. Anybody need any pen or pencils?
Yes, sir.
I'm just handing them out a bunch because they're, I don't know how many are sharp.
Almost done. What's today's date, sir?
29th?
Okay. Will we get test results today?
Yes, sir, you will get test results today. So while you guys are taking your test, just real quick, we're going to go over just so that does everybody feel comfortable with the objectives that we're trying, that we had covered here today, such as the description, inspection, cleaning, and maintenance of PPEs, conditions that require the use of respiratory equipment, the basic components of an SCBA, components of the SCBA itself, specific limitations of the SCBA, and the process of inspecting and cleaning, as well as safety considerations for working in and exiting hazardous atmospheres while wearing an SCBA, as well as the routine inspection and cleaning procedures. Does everybody feel like these objectives have been met?
Yes.
If they do not, please contact me offline or see me after class. Thank you. Thank you. Thank you. Thank you. All right, gentlemen, well, thank you for your time. I appreciate it. If you have any questions, please see me after class.
Thank you.
Thank you.